The pictures came back yesterday, before and after. A quiet stretch of the moon's western limb, unchanged for hundreds of millions of years, and now marked. A darkened patch, a halo of ejecta, a crater that did not exist last week. South Korea's Danuri orbiter released the images, and for the first time, the world saw with its own eyes what happened on August 5th. A discarded SpaceX Falcon 9 upper stage, 12 meters long, roughly 4,000 kilograms of dead metal, hit the moon at 5,400 miles per hour. Nobody planned it, no mission required it, no law prevented it. And here is the part that should bother you. NASA's response was not alarm, it was a shrug. And that shrug is the story. Because the reason NASA is calm is not that nothing dangerous happened. It is that nothing was ever supposed to stop it. That is where I want you to start listening carefully. Because everything you are about to hear is real. The vehicle is real. The impact is real. The coordinates are real. The images are real. And the reason this event slipped past every regulator, every treaty, and every safety architecture on Earth is also real. If you are watching this from the United States, from Europe, from Asia, from anywhere on this planet, take a second and think about where you are, what time it is, and how strange it feels that a private American rocket just added a fresh scar to the moon while you were asleep, and almost no one you know is talking about it. That silence is not accidental. That silence is the first clue. What NASA said in public was that the impact posed no danger to Earth. What NASA said in public was that meteoroids with the same energy hit the moon roughly every 6 days. All of that is technically true, and all of that is designed to make you stop asking the harder question, which is not whether this one impact hurt anyone, but what it proves about the system that let it happen. A rocket hit the moon, and the most alarming part is that no one broke a rule. Let me tell you the version most outlets ran with, because that version is the frame we need to dismantle. The public story goes like this. An old Falcon 9 second stage, left over from a January 2025 launch that sent Firefly's Blue Ghost lander and iSpace's Resilience toward the moon, ran out of fuel in a high orbit and could not be safely deorbited. Gravity and sunlight nudged it around for 18 months. Astronomers tracked it. They predicted the impact to within a minute. It hit near Einstein Crater on the sunlit western limb of the moon, so nobody saw a flash from Earth, but telescopes in Chile and Arizona caught the ejecta plume. NASA said no danger. The administrator himself, Jared Isaacman, went on television and said, quote, "It is not a big deal right now. The moon has clearly seen better days." And that was that. A quirky space story. A little embarrassing for SpaceX. A little exciting for planetary scientists. Move on. Now watch what that framing quietly ignores. It ignores that this stage was not tracked because anyone was legally required to track it. It was tracked because one retired programmer in Maine, Bill Gray, runs a small orbital tracking site called Project Pluto and noticed it. It ignores that 18 months earlier, in 2022, another rocket stage hit the moon, and Gray originally identified that one as a SpaceX Falcon 9 too, before a University of Arizona team proved it was actually a Chinese Long March 3C from the Chang'e 5 T1 mission back in 2014. Think about that. The last time the internet blamed SpaceX for hitting the moon, they were wrong. This time, they are right. And in both cases, no one on Earth had the authority to prevent it. That is not a reassuring story. That is a pattern. It also ignores that Bill Gray himself, the person who tracked this stage all the way to impact, said publicly that the event highlights, quote, a certain carelessness about how leftover space hardware is disposed of.
The person closest to the data does not sound like Isaacman. He sounds worried. And that gap between the operator and the administrator is the first honest signal in this entire story. Now put this in historical context, because this is not the first time humans have crashed hardware into the moon. In October of 2009, NASA deliberately drove a spent Centaur upper stage into Artemis Crater near the lunar South Pole. That mission was called L-Cross, and it was not an accident. It was a science experiment. The stage hit at about 2.5 kilometers per second, excavated roughly 350 tons of regolith, and confirmed the presence of water ice at the South Pole. That impact was planned for years, coordinated across multiple observatories, and published in a peer-reviewed paper in Science. Every measurement was calibrated, every observer knew the coordinates in advance, every gram of ejector was counted. Before that, in the Apollo era, NASA deliberately impacted spent Saturn upper stages and lunar module ascent stages onto the surface to generate calibrated seismic signals for the seismometer network the astronauts left behind. That network operated from 1969 to 1977 and catalogued more than 12,000 seismic events. Every one of those impacts was intentional. Every one of them was scientifically useful. And every one of them was coordinated inside a program that treated the moon as a laboratory whose surface had to be respected. Compare that to what happened on August 5th. A rocket built by a private company, launched by a private company, ran out of fuel because the mission profile did not budget for a safe disposal, drifted for 18 months because no rule required otherwise, and hit the moon because gravity finally aligned it with the surface. Nobody chose the site, nobody chose the timing, nobody wrote a paper in advance. The only reason anyone even knew where to look was because an amateur tracker in Maine kept refining the numbers until the last hour. That is the difference between a spacefaring civilization and an accidental one. And we are watching the transition from the first to the second happen in real time. Here is the mechanism that actually put this rocket on the moon. When a Falcon 9 launches something toward deep space, the second stage does most of the heavy lifting. It burns almost all of its fuel to give the payload enough velocity to escape low Earth orbit and head toward the moon or beyond. When the payload separates, the second stage is left in a very high, elongated orbit around the Earth, with almost no propellant left. Deorbiting it into the Pacific requires a burn. That burn requires fuel. The fuel is gone, so the stage stays up there, tumbling, drifting, at the mercy of the two forces that dominate physics at that altitude: Earth's gravity and the pressure of sunlight. Photons carry momentum. That momentum is tiny, but over months it is enough to reshape an orbit. The sun literally pushes the empty tank around. Add lunar gravity every time the orbit swings out far enough, and you have a chaotic trajectory that no one can predict more than a few weeks out. Now, here is the part that should bother you. This is not a rare situation. Every deep space Falcon 9 mission that does not have enough leftover propellant for a controlled disposal creates one of these ghosts. Same for other providers. Same for anyone who launches beyond geostationary orbit. There are dozens of these things drifting in cislunar space right now. Nobody keeps a public master list. Nobody assigns responsibility once they leave low Earth orbit. And the physics that just put this one into the moon is the same physics acting on all the others. That is the mechanism. That is why this happened. And that is why it will happen again. The impact near Einstein was not a fluke of orbital mechanics. It was the predictable output of a system that generates uncontrolled objects and then hopes gravity puts them somewhere convenient. Sometimes gravity chooses the sun. Sometimes gravity chooses the moon. Sometimes gravity chooses something we have not yet had the imagination to worry about. Now let me show you the weak point hidden inside all of this, because it is not what most people think. The weak point is not SpaceX's engineering. Their engineering worked. The payload got where it was going. The weak point is that the system for cleaning up after these launches, once you leave low Earth orbit, does not exist. On paper, it looks like it should. The Federal Communications Commission has a 5-year deorbit rule for satellites, but that rule applies to Earth orbit, not deep space. The Federal Aviation Administration once considered a 25-year rule for upper stages, but withdrew it. And the FCC's new Part 100 framework, published in July of this year, actually created a category called cislunar spacecraft, and then imposed no disposal mandate on that category at all. Read that again. Regulators created a name for the problem, then they did nothing about it. The Outer Space Treaty of 1967 says nations are responsible for objects they launch, but does not say what responsibility means once the object is dead. The Artemis Accords, which just reached 70 signatories when Mauritius signed on July 17th of this year, commit parties to debris mitigation and heritage site protection in principle, but impose no binding rule on the disposal of a spent upper stage headed toward the moon. This is not a loophole. This is the entire architecture. What looks like a robust international framework is, in practice, a series of polite intentions with no enforcement mechanism, no penalty, and no regulator with jurisdiction. When Isaacman said this was not a big deal, he was technically right about this one crater. But the reason he was right is not that the system worked. The reason he was right is that the system was never asked to work in the first place. SpaceX, to its credit, appears to be voluntarily reducing how many upper stages it strands in high orbit. But voluntary is not a rule. Voluntary lasts only as long as the profit margin allows. Voluntary is what you get in the absence of governance. And voluntary is exactly what fails first when the industry gets crowded. Now let me break the assumption that scale will fix this on its own. Because a lot of people, if they think about lunar debris at all, imagine that regulators will catch up eventually and the problem will stay small until they do. That intuition is wrong, and here is why. Right now, the amount of human-made material on the moon is estimated at around 200 tons total. Every Apollo descent stage, every Soviet lander, every crashed probe, every rover, alive or dead. That is the accumulation of 66 years of lunar activity. In the next 10 years, NASA's Commercial Lunar Payload Services program alone plans dozens of landers. China plans a permanent research station near the South Pole by the mid-2030s. India, Japan, and Europe are all lining up missions. And Artemis, if it survives its current schedule fight, will begin putting crewed hardware, habitats, and cargo landers on the surface in volumes we have never approached before. Here is the math that breaks the fantasy. If lunar traffic grows by a factor of 10, the debris does not grow by a factor of 10. It grows faster than that, because more traffic means more failed missions, more discarded stages, more off-nominal landings, more collisions between objects in cislunar space that then rain down as smaller debris. A single Falcon 9 upper stage hitting near Einstein Crater is a 1 in 50,000 event on the current map. Multiply the launch cadence by 10, and you are not multiplying the risk by 10. You are entering a regime where the same physical space is being asked to absorb an order of magnitude more uncontrolled objects, with no cleanup, no oversight, and no shared rulebook. That is scale rupture. A slightly bigger version of what we are doing now is not a manageable version of the same problem. It is a fundamentally different problem, and nothing in the current regulatory conversation is designed to handle it. We have seen this exact pattern before in low Earth orbit. For decades, spacefaring nations treated the region above 200 kilometers as effectively infinite. Now it is choked with debris, tracked collisions are annual events, and every satellite operator plans around a growing risk that was called negligible right up until it wasn't. The Moon is starting that same curve, from a lower baseline with even less regulation. Anyone who tells you the two situations are unrelated is not paying attention. Now let me pull this out of the abstract, because so far I have been talking about crater sizes and treaty language, and that is not where this actually lives. It lives in bodies. It lives in the astronauts NASA plans to land on the lunar South Pole under the Artemis program, sometime around 2027 or 2028. It lives in the crews China plans to send. It lives in every human being who will spend time on that surface, unshielded from the sky, dependent on hardware that has to work. A team of scientists, led by Benjamin Fernando at Los Alamos National Laboratory, modeled the ejector from this impact and concluded that resolved particles could travel nearly 1,000 kilometers from the impact point. That is not a warning about this specific crater. That is a warning about the physics of every future accidental impact. Debris on the Moon does not settle politely. In a vacuum, with 1/6 Earth's gravity, ejector moves fast and far, and once it is in motion, nothing stops it except the ground on the other side of that trajectory. Think about what that means for a crew standing on the South Pole while a spent stage, unshielded and untracked, comes down 200 kilometers away. Even a shard the size of your fist at hypersonic velocity has the kinetic energy of an artillery round. Their habitat is not armored. Their spacesuits are not armored. Their vehicles are not armored. And the surface itself becomes the weapon, because primary impact ejector then becomes secondary impact material that scatters even further. Let me translate the numbers. This one impact released roughly 14 billion joules of kinetic energy. That is the equivalent of about 3 tons of TNT, delivered in a single instant, into a surface with no air to dampen anything. On Earth, an atmosphere would slow the debris, spread the energy, and reduce the range of the ejector to a few hundred meters at most. On the Moon, the same energy launches material 1,000 kilometers away. That is roughly the distance from New York to Chicago. Imagine an artillery shell fired from Manhattan, arriving in downtown Chicago intact. That is the physics you are dealing with. And now imagine that shell is one of dozens generated by a single accidental impact, scattered across a surface where any future base has to sit somewhere. This is not science fiction. This is what happens when you keep dropping heavy objects onto a surface that has no atmosphere to slow anything down. And this is the human meaning that the phrase, "not a big deal," is hiding. There is also the psychological weight, and it should not be dismissed. Astronauts on the ISS live inside a magnetic field, inside the atmosphere's outer layers, inside a station that has been operational for decades and is checked constantly from the ground. Astronauts on the Moon will live inside a habitat resting on a surface where any object anywhere on the disk can become a threat with less than a day's warning. That is not the same job. That is not the same risk profile, and that is not the same kind of person who will volunteer to do it once the first serious near miss makes the news. Now widen the frame, because it is not just about a crew being hit. It is about a surface that is supposed to support long-duration presence and about the systems that presence depends on. Solar arrays, communication antennas, water extraction hardware near the polar craters where the ice actually is. Every one of those is fragile. Every one of those has a finite service life. And every additional uncontrolled impact somewhere on the moon adds a small but non-zero probability that a piece of debris lands where it does not belong. Multiply that over decades of build-up, and the risk is not that one crew gets unlucky. The risk is that the operating environment becomes progressively less predictable and progressively more expensive to defend against, until the economic case for a permanent lunar presence quietly erodes from underneath the mission. That is the logistics problem, and it does not stop there. Because every solution proposed so far requires launches. More propellant to deorbit spent stages requires more fuel margin on every mission, which reduces payload capacity, which increases cost per kilogram delivered to the moon. More tracking requires more ground stations, more satellites in cislunar orbit, more staff, more funding. More shielding on lunar hardware requires heavier landers, which requires bigger boosters, which requires SpaceX's Starship to actually work at its promised cadence, which currently requires 10 or more orbital refueling launches per Artemis mission, a capability nobody has demonstrated yet. Starship's most recent test, Flight 12 back in May, saw the ship reach its target and splash down safely, but the Super Heavy booster failed its boost-back burn and crash-landed. The vehicle that is supposed to carry humans to the moon still cannot bring itself home reliably. And it is that same vehicle whose upper stage variant is meant to be the lunar lander. The system that is supposed to make the moon useful is the same system that is quietly accumulating the debris that could make the moon dangerous. Every fix costs money. Every cost pushes timelines. Every timeline slip pushes the political tolerance for the whole program a little closer to its breaking point. Now, let me show you why the official tone stays calm anyway, because this is where the story sharpens. NASA's public statement on this impact was written by a public affairs specialist named Jimmy Russell and cleared by a responsible official named Abigail Bowman. The language was carefully chosen. Poses no danger to Earth. Constantly absorbing impacts. Collect lunar data. Refine techniques. Every one of those phrases is defensible. Every one of those phrases is also strategic. Because NASA in August of this year is not a confident agency. It is an agency in the middle of an open political fight over the Artemis III lander contract. Last October, then acting administrator Sean Duffy said he would open up the contract because SpaceX is behind. NASA solicited acceleration plans by October 29th and issued a request for information from other providers, meaning Blue Origin and potentially others. The Artemis III landing has slipped to no earlier than mid-2027, with a realistic date closer to 2028. Now overlay this impact on that political fight. A SpaceX rocket stage, from a mission that carried SpaceX's own commercial payloads, just hit the moon accidentally during the exact window in which NASA is deciding whether to keep SpaceX as the sole crewed lunar lander provider. Isaacman, who took over from Duffy, is a private sector figure with well-known ties to the commercial space industry. Do you think, at that particular moment, NASA leadership had any political incentive to publicly frame this event as concerning? Of course not. Framing it as concerning would strengthen the case that SpaceX cannot be trusted with the lander.
Framing it as routine keeps the contract intact.
Framing it as a natural phenomenon that happens every 6 days makes the entire issue disappear from tomorrow's news cycle. This is not corruption. This is not conspiracy. This is normal institutional behavior under political pressure. And it is exactly why the public tone almost never matches the underlying physical reality when a private contractor makes a mistake that reflects poorly on a public program. Compare this to how NASA talked about the space shuttle in the years between Challenger and Columbia. The official tone was that the vehicle was safe. The internal engineering data said something quieter and harder. And the gap between those two versions of reality is exactly how you get from a program that flies to a program that grounds itself in shock. History does not repeat, but it rhymes. And the rhyme here is loud enough to hear. Now step back, because the impact near Einstein Crater is not really the story. The story is what this impact tells you about the trajectory of the next 20 years. We are entering a period in which private companies will conduct more lunar activity than every government on Earth combined has conducted in history. The infrastructure to govern that activity does not exist. The infrastructure to track it barely exists. The infrastructure to clean up after it does not exist at all. And the political incentives inside the agencies that are supposed to build that infrastructure are aligned against slowing down the private companies whose speed the agencies now depend on to meet their own goals. This is the civilizational layer. The Moon has been, for 4 billion years, a stable body. Its surface preserves a record of the inner solar system's history in a way no other accessible place does. Every crater tells a story about an asteroid or a comet that struck at a specific speed and angle. Every layer of dust records solar wind exposure over billions of years. Silvio Sinibaldi, ESA's planetary protection officer, put it plainly in a paper this year. "Our activity," he wrote, "can actually hinder scientific exploration. If we contaminate the record with anthropogenic impacts we cannot easily distinguish, we lose the ability to read it. The Moon becomes less useful as a scientific archive at exactly the moment it becomes more useful as a commercial destination. That is the trade the current system is quietly making, and no one has ever been asked to consent to it. The Moon also holds the archaeological record of our own species' first steps into deep space. Tranquility Base, the Apollo footprints, the Surveyor probes, the Soviet lunar landers. The World Monuments Fund has already listed the Moon as a threatened historic site, and every off-nominal landing, every stray impact, every rogue upper stage is a potential threat to that record. We are, quite literally, in a position where a rocket could destroy the site of the first human footprint on another world, and there would be no law to prosecute anyone under. Let me be clear about what I am not saying. I am not saying exploration should stop. I am not saying SpaceX engineers are careless. I am not saying NASA is lying. I am not saying this specific impact will kill anyone. Every one of those framings would be wrong. What I am saying is narrower and, I think, harder to argue with. The public story is that a rocket hit the Moon. NASA said it was fine, and everyone moved on. The real story is that a rocket hit the Moon because no framework required otherwise. That NASA's calm was politically calibrated. That the underlying regulatory gap is now the operating assumption of an entire industry. And that the scaling curve for lunar activity in the next decade will convert this one impact from a curiosity into a preview. Here is the verdict, and I want you to hold it in your mind the next time you see a headline celebrating a private lunar mission. The crater near Einstein was not caused by negligence. It was caused by the absence of rules and by an industry, an agency, and a treaty system that have all quietly agreed not to write those rules yet. That absence is not going to correct itself. It will correct only when the cost of not correcting it becomes visible, which usually means someone loses a mission or a crew or a piece of infrastructure they cannot afford to lose. That is how governance in space has always worked. We do not fix the gap until the gap kills something. Look at every major safety reform in aviation, in maritime shipping, in nuclear power, in orbital operations. Every one of them was written in the language of a specific disaster, and every one of them arrived years after the warnings that could have prevented it were dismissed as premature. The warnings for lunar debris are being dismissed as premature right now. On television, in press releases, in administrator interviews, in treaty documents, in an industry whose economics currently reward speed and punish caution. And the thing about premature warnings is that they only look premature until they don't. The engineers who warned about the space shuttle's O-rings were premature. The engineers who warned about the foam strikes on Columbia were premature. The engineers who warned about aging debris in low Earth orbit were premature. Every single one of them was proven right. Every single one of them was ignored until the specific event they warned about actually happened. The pattern is not that the warnings are wrong. The pattern is that institutions do not act on warnings, they act on funerals. Go back to the image that opened this, the before and the after, the unchanged surface and the fresh scar. That is what an unregulated frontier looks like from 400,000 kilometers away. Quiet, unremarkable, and permanent. Nobody panicked. Nobody had to. The moon absorbed it the way it absorbs everything, and the news cycle moved on. But the next one is coming, and the one after that. And the one that finally does matter will look, in its first hour, exactly like this one did. A shrug from NASA, a statement that no one on Earth was hurt, a quiet update from a Korean orbiter, and a small dark mark on a place that used to be undisturbed. That is the warning. Not that this event was catastrophic, but that the system is designed to keep telling you it wasn't, right up until the moment it is. Remember the image. Remember the silence around it. And the next time someone tells you it was not a big deal, ask them who exactly benefits from you agreeing.